would you help like integrate certain pieces of software, or like where's like the line, because you guys are like cloud
Yeah, so
infrastructure,
there's
right?
a number of steps in conversations we take to determine where that line is. But in respect to enterprise support and technical account managers, we validate system specifications, we help profile, performance of your workload. We kind of help you kind of do research to make the best decisions. However, there are times when, even if we have, made a bunch of recommendations, our job is not to be hands-on keyboard. So we can talk through points of integration, but in order to build those out, we do recommend going with our professional services or our consulting partners. And then, on the other side of that, let's say they went with our professional services or any number of consulting partners, they would help scope out and build, but then we'd be there as a technical account manager, as well as the account team, to validate, the architectural plans, and just be there for, when they start to build out, because as a TAM, you would have to sometimes coordinate between support engineers and operations folks at customer sites, just to make sure, hey, we're going through this project. This worked in non-production, here we are in production, and that's where we come in to really understand, oh, well, we know XYZ company has, security controls in this area. Maybe you're hitting a 404 because of some security rule. We'll come in and help with that. But generally speaking, my role doesn't entail putting hands on keyboard, but we do kind of have access to different areas to help with the analysis of what to build out.
Cool. Thank you so much. So I know we have like a pretty small group today, but we're going to be recording this workshop and then we'll be sending it out afterwards. Just because the submission is due like later today, I think people are too busy working on that. So if it's all fine with you, we can get started.
Oh yeah, no problem. Let me share my screen. Oh, could you enable screen sharing for my user?
Yeah, try it again.
Okay. Oh yeah, cool. Right. Can you guys see my screen?
Yep.
Okay, 1 second. It's gonna stop my video for bandwidth issues. Sorry about that. Okay. So today we're gonna talk about conversation stories, Lex, Alexa, and beyond. If we have time, I want to walk through where Lex and Alexa fit within the AI/ML stack, but in respect to the hackathon, we want to get through this content as quickly as possible so we can jump right into more of the hands-on stuff. But hopefully, if we have time, I should show you the context of where this sits within our AI/ML stack. Okay, so, on AWS, what do customers really want to do? So I know Jonathan's first question to me was, what do I do at AWS? And kind of gave you a general overview of what my role would entail working with customers. But more importantly, from the customer side of the house, they want to build, they want to move fast, and they want to stay secure. And again, security is job number one, both at AWS and working with our customers. So when we focus on the builders, we want to focus on what differentiates. And again, the time to take from ideation to deployment and instantiation definitely can vary, but taken together with the account team and everything that we can bring to fore, we help customers accelerate and move very quickly into an idea to something to be deployed. And again, with AWS's global network, security is job number one. Part of what our role, as well as any number of different folks at AWS, we want to make sure that customer workloads are secure, compliant, and overall meet their compliance standards. Okay, so this right here, just want to very quickly walk through the advent of conversational interactions. So In terms of the first generation of humans interacting with machines, it was definitely machine oriented, where you would have, again, to this picture here, you have a woman as a telephone operator. And years ago, before there was, hardware to do the switching, an actual human had to go in a switchboard and, take your wire and connect it to another accompanied wire to make a long distance phone call. And then, decades before that, we were already, humans sending out messages via the telegraph, through the wire. So this particular type of interaction hasn't really gone away, but for the most part, we have evolved. There are cases where there are still telephone operators, but that's very, very specific use cases where a human needed to patch over to a closed loop system. But for the most part, we don't see that too much because of the advent of the second generation with more of control oriented, where there's an interface abstracted away from a machine. So, the easiest context would be, rather than punch on a physical machine to send out messages, we have an interface, whether in a web browser or in a mail client, we're easily able to send messages. For the folks here on the line, you're no stranger to this, but even for me, I'm aging myself. I remember, in, I want to say 6th grade or something, email was coming about, and we could send electronic mail, and everything was a context around, what we kind of knew in the physical world. That was kind of a place where we were at for almost a couple decades before, again, the introduction of smartphones and smart devices, where, again, we're further abstracting away from an interface on a web browser to something directly in the palm of your hands. But in the whole grand scheme of things, we are still in a control-oriented and translated environment where humans are interacting with machines. And now we're kind of headed into the third generation. And I know, with the advent of, chatbots and all that, well, what's important to work with chatbots is something called natural language processing. And we'll get into that after. But, intent oriented is where we can say, we can move from any number of actions into a single, intent to let the machine know what you really want. So if you look at this picture to the right here, in a normal situation in the second generation where we're interacting with an interface, you would have either on your phone or a web browser, you log into something. Let's say your Word editor, and in order to get that document, you have to click File and find it. And once you pull up the file, you have to identify the format. And once you identify the format that it's compatible with your editor, and only then you can gain access to the document in order to make changes or review something. On the flip side of that, with an intent-oriented interface, you're literally just asking a machine or a computer or the AI, can you find project X in a Word? So just like that, in one sentence, you're able to accomplish what you did in 5 or 6 clicks to the left. So taking that together, that's what customers really want in terms of retrieving information as very quickly as possible to present to the user in order to enhance the user experience. And now we definitely know many times what the user is looking for, maybe a bit more in depth, but at the very least, in terms of customer experience, we're accelerating the time it would take to put something in front of the customer's screen. So with Amazon Lex, we're able to very quickly create chatbots, and we deploy very quickly. It scales. Again, we're at AWS. The underlying service and the hardware infinitely scales depending on your use case and usage patterns. With Amazon Lex, we're able to build business logic. So it's not just about, hey, it's a cool chatbot, but this chatbot can collect a whole host of information, and based on the things that it collects, it can then very quickly push into, applications that perform additional business logic. Taken together between integrating your chatbot with other applications, again, as I mentioned earlier, security is job number one. And then all the things that you do within your chatbot, you're able to analyze, monitor, kind of tailor it for very specific audiences based on the logs it collects and the insights that you glean from your analytics of your usage of your chatbots. And then when I mentioned the title with Lex, so Lex is also the same technology driving Alexa. So again, with natural language processing and our services, we're able to take text to speech and speech to text. But let's quickly go on. Some of the use cases. I don't want to bore everyone with slide reading off use cases, but right in the middle, application bots. So today we're gonna get right to it and create a coffee ordering robot. And what we're gonna do is this coffee express robot will take your order. And then fulfill your order. And then we're going to, and as it's doing that, you're going to see some of the outputs of the bot itself, where it will, the outputs would generate into a JSON file, and the JSON can easily integrate with your web application. So in a scenario of a coffee express bot, it's one thing to have, a chatbot that on a web browser, but if you're in a kiosk situation and it collects all of your order information, where does that go? And because it outputs in the JSON, it can easily integrate with an order management system to receive that file, parse through the file, and then ingest, very specific details to process that order. So that's what we're going to get into in a moment right here. But before I move forward, are there any questions? Okay, great. As you know,
yeah, I have a question.
Absolutely.
Oh, okay, so like here it is application bots. Like, what does it mean?
Yeah, so I wanted to focus on that in the next slide. So an application bot is to say you have an application already existing, whether it's a order management system, but an application bot could then say, this could be instantiated into a different interface where you're collecting the upfront information in order to integrate to the back office system. So in this case, like a kiosk, right? You're at an airport, there's a kiosk, but then, we don't have a large restaurant at an airport. So there's just like this one coffee station, and there's only 2 people working. You'd want to, augment, that labor to a kiosk. Kiosk can collect all that information and then send the order flow into to fulfill that order. So that's what we're going to get into. But just for the sake of the audience here, I think we're no strangers to contact center bots. We want, whether even you're interacting with something on Twitter, I would imagine a lot of that is a conversation bot somewhere in some data center, interpreting tweets, things like that, your banking and all that. Informational bots kind of, as you know, sometimes you log onto a website, it's like, hey, can I help you? I guess we're no stranger to that. And on the right of these things at AWS, we're still working with customers on how to really think through what an enterprise productivity bot is. But I can safely say, as a TAM at AWS, we do have a Slack bot where we can ask certain questions real quick, even if we don't know, for reference, and it will generate links and stuff, as we're working with our account teams and clients. So definitely say definitely being worked on, as customers know how effective chatbots can be. The world is now ready to interact with enterprise bots. Okay, anatomy of a conversation, and we're going to walk through this when we're going to create our chatbot, we're actually going to step through what utterances are. It's kind of words you speak to let the bot know what your intentions are. Intents are things that we can program to let the bot know these are the intentions. When you hear this, what will you do? And then the slots are, when we ask the question, what will you do with this intent? Slots are areas where those intents will connect to a slot, and a slot can also be thought of as an entity. Things like in our coffee bot example, an entity could be espresso, cappuccino, a mocha or a latte. That's an entity, and then based on that, we can start organizing our order flow. That being said, before we get into chat, our coffee bot, just kind of looking through the interaction of what I was just saying. Book a hotel, that's the intent. So the input that we're collecting will definitely help with ordering a hotel or a coffee. Utterances, as I mentioned, is spoken word or a phrase, and we're going to get into, creating those in our workshop. Slots, again, an entity, a city, a place, anywhere, anything. And then, fulfillment is when it collects all of it, does its specific logic, whether it takes everything is collected, goes off and performs another function via Lambda or pushed into another system. Once that is completed, the fulfillment is now completely completed. Okay, so now that we kind of walked through the flow of conversation, let's dive right into the console itself. Share my web browser, everyone, sorry. Okay. Okay, so what we're going to do in the first part of this is we're going to create a bot. But before we do that, I just want to set the context. Within a bot, your bot has at least one language. In this case, we're just going to use English, but with Amazon Lex, we can have a whole number of different international languages. And then with your languages, optionally, it could either connect to a Lambda and has at least one intent. Now, for our Coffee Bot Express, we don't really need Lambda for additional business logic, but the option is there for you. What we really require are our intent, like what do we want to let the robot know as a customer, what do I want? And then within your intent, you have to have at least one utterance. An utterance is a phrase or something to initialize your bot. And a slot, as I mentioned, could be an entity, where, how many, a thing, what have you. Okay, so let's say we logged into AWS. This is your AWS console. And all we're going to have to do is just hit Lex. So Lex is our voice enabled option. Here, we're going to create a bot. When we create a bot, as I mentioned, we want a blank one. We're going to name it bot, all the rest. We're going to use an existing role. And again, for the folks who don't have AWS experience and IAM permission, it's kind of like role-based security. And generally speaking, if we don't have an existing one for new users of the Amazon Lex service, you create a role, and that will just create a role that can only have access to Lex and not anything else, because you have to explicitly allow services to talk to one another. Again, security is job number one. So we're kind of more explicit, deny all, explicit allows. And very specifically for this service, we're not doing any collecting any, information from kids or anything. So I'll hit no. And that's the general flow of creating your bot. But just like in cooking show, I already kind of like baked something for you. So all that information, I just, named it. So now I have my bot. And then once you have your bot, you have your intents, as I mentioned. I have two intents here. First intent is how I just want to initialize the bot, whether it's like, hey there, are you open? Is anyone there? When you provide these utterances, the bot will hear it out and process that language and say, these are the utterances that I programmed to listen in on. And then based on that, it's going to prompt you. So the way we built the spot was say, if someone is asking, hey there, are you open? Or is anyone there? It's going to then give you this welcome message. You'll see in a couple minutes, but this is our first intent. But let's say, you successfully initialize the bot and it knows that you're there. So then it's going to start to go through its other intent, which is to fulfill your coffee order. And in this case, very simple. You're asking, can I make an order? Or I'd like to order a coffee. then you'll see here in brackets, types of coffee. And within my types of coffee, I can kind of build out any number of different values associated with that slot. So again, type of coffee is the slot. How many types does this can my coffee robot help fulfill? Well, we have espresso, regular coffee, cappuccino, mocha, and a latte. If I go back to the custom order, that'll initialize, the next question, would you like that hot or iced? If you see, this maps to my temperature coffee, and I go to my slot type of temperature coffee. That's type, sorry. Temp coffee, either iced or hot. And then, as you know, when you order coffee, it's gonna what type of cream, and this one's actually pretty, as you know, there's so many options now, and I'm probably missing some of the newer ones, but you have almond milk, soy milk, half and half, cashew, and all the rest. So it's really infinite in what you can kind of, add to your slot type. So just think of an order fulfillment system, based on your categories. You can have so many different values per category. So that's what we're doing here. So now that we kind of have the flow of it, so again, we're going by this flow here. I have my utterances. So I shared what I wanted with the bot, and it's going to go through all these options. And these options is when the interactions occur, and the interactions are definitely for Lex, it's text to text. So we're inputting English language text. It's going to process that and output something. So very simple kind of bot. I'm just going to hit build. Okay, so as you saw, anyone there, as you can see, it's one of my utterances, and it very quickly was prompting me for what I, kind of written here. So I'm interacting with my copy. Copy. Whoops. Oh, it's going to throw up on me. Oh, no. Okay.
Is it looking for the word order? Like, I'd like to order coffee?
Oh, yeah. Good call out. Sometimes, good call out right there. Sometimes we have to, when we test these things, we do catch, some mistakes that we're making, because again, this is a computer and it has to explicitly be told what it wants. As you caught that, I just put, I'd like a coffee when, one of my intent here, or my utterances in this intent is order. So good call out there. Thank you for that. So I'd like to order a coffee, and now we're back in the flow of the conversation. I'd like it hot. Let's say regular milk. Why not? Okay. So all these interactions you've seen here are, based on what we type, but more importantly, also from a technical perspective, you have your JSON details. So you can easily output this and send this request to a web service that's available to receive orders, or in the old ways of business systems, it would output the actual file, and then there would be like a batch process that would like check to in the location to receive that file. And then again, it'll just parse through this file. But if you look at the summary, it parsed through the file. So you can easily see this could feed into an order management system with type of coffee, temperature of coffee, and the cream type. So this is on Lex, and you can build this in your UI. But again, Lex also powers Alexa. So I just wanted to go through the exercise of how do we take this and create an Alexa skill. Again, very easy. If we just hit export, we have version 1 of this, Alexa skill. And then we would just name the Alexa skill. And that's it really. And then when I say Alexa, Alexa also has its own developer console. So Alexa itself, you can be an Alexa skills developer, but you don't really need to be in AWS. And for the most part, most of the skills that people create on Alexa are written in Python or just directly within the developer console. But the option is there to integrate this skill with other AWS services. And the way you would do that would, again, be an IAM permission with roles and responsibilities. But in this case here, everything that we want to do has already been created in Lex. So all we want to do now is just import your Alexa kind of export JSON file. So again, it's very easy. You just put test. We want custom. Provision our own. Create the skill. We want to start from scratch.
How this happens, I have like 2 questions if I could ask.
Absolutely.
So for the Amazon Lex, like as we saw, it if you didn't have the keyword order, it wouldn't order it for you. So like I have an Alexa and whatever I say, it will respond as an answer to something. So how do you guys go about like where do you guys kind of get the data set, I guess, in a way?
Yeah,
from
that's a
other
great
people?
question. So in this one, we go to monitoring. It will show, things that, it could not interpret. I think it takes a day for all this to come in, but you can set how frequently this will get updated. I think I just took default. So it's every 24 hours, but in a large kind of environment, you'd want every 10 minutes just to make sure that you're monitoring the right things. And if it's not interpreting the questions correctly. This is Lex. In terms of your Alexa, again, same concept, we'll go through that. So I definitely have that in the follow-ups here. But that's a great question.
Also, is it possible to go on the console by yourselves and actually build a Lex if you wanted to? Like if someone wanted to use it as in like their project or something, I don't know. Or if I just want to like do it for a demo, is it possible I can go onto the console?
You can. So all you really need is well, you're talking about Alexa or Lex?
Lex.
Yeah, so all you really need is your AWS account. Once you log into your AWS account, you can search through it here or very quickly just punch in Lex. And then right when you're in the service itself in the console, you're ready to create the bot.
Okay, cool. Thanks.
Yeah, that's all. Later on, I'll share. We also have a workshop that will walk you through a lot of this stuff. So if you're interested, I can share that as well. Okay, so let's say I imported that JSON file. I'm in here, but I just wanted to show everything that we created in Lex shows up here now. So again, I didn't really have to rekey in the information. Pretty simple export, import, and again, we're ready to test your Alexa. Or actually, before I get into it, if we go back to build. Okay, cool. All right. Start CoffeeBot Express.
Launch request.
Hi there. Anyone there?
Welcome to the CoffeeBot Express. We offer 5 different options at this time in either hot, iced, or frap. We have regular coffee, latte, mocha, cappuccino, and espresso. We will be adding new options soon. Stay tuned. Would you like to order one of the 5 options?
I'd like to order a coffee.
How many?
3?
What type of creamer would you like in your order? We have 2%, whole milk, skim milk, soy milk, oat milk, almond milk, cashew milk, and cream.
Cream.
Can I have a name for your order? What size would you like your coffee? We have small,
Large.
medium.
Whoops.
Would you like that hot, iced, or frapped?
Hot.
Thank you for your order. I have 3 hot coffee with cream for Randy. Is this correct?
Yes.
Intent, order coffee. Locale, NUS. Slots, temp coffee, hot. Size coffee, large. Type of coffee, coffee. Customer name, Randy. Creamer type, cream. Count coffee, 3. Confirmation status, confirmed.
Okay. So as you saw with the flow here, not too much difference with our Lex kind of interaction, but now it's an Alexa skill. You can very easily push this into an Echo device. But to the gentleman's question on kind of where we're seeing how it's interpreting and the data set. So if you look in the left here, as you're interacting with Alexa, very similar with Lex as well, you're going to have the request kind of inputs, and then you're going to have the outputs of those requests. And this is kind of where you can take this JSON again further and then push this or have another system ingest your order. So this is your JSON. This could very quickly easily be interpreted and then generating a receipt, etc. Also in the console, how like if you have an Echo Show, you can also start playing around with graphics and what the users would interact with if there was like a touchscreen option. Okay. So if you click device log, again, you have further data sets to interpret what's happening with your interactions. So you have timestamps. It may show areas where Alexa kind of tripped up. And then you can start to improve, areas we can identify, if there's an error, it could have been a typo, or as you saw or caught earlier, one of my responses did not include the word quote unquote order. But then, how do we make this machine smarter that it would kind of fill in the blanks if you don't say order? The next time I do my training, I could flag that and say, that could be a synonym. I'd like a coffee could also translate into I'd like to order a coffee, and you can then improve it. But we wouldn't know that until there was errors. But so that's an area of focus that we're trying to improve for users, because right now it's very technically laborious to parse through all this. But within the console soon, we're going to introduce an area where you can just kind of start clicking out all the errors and then just making changes within the console versus parsing through a file and do it programmatically, which I believe if you're a programmer, you'd want to do that. But I know business users would want to just jump in, know what wasn't working, and then very quickly make modifications. Any questions? Okay, great. So we're looking good on time here. So what I'm going to do is kind of switch gears and just kind of describe, everything you saw and how it fits into the wider AI machine learning stack on AWS. Give me 3 seconds. Where is this guy? Sorry about this. 1 second. Oh, found it. Okay, so this is the Amazon machine learning stack. I'm going to walk you through from the bottom to the top here. generally speaking, the foundational components of all our AI ML services are, Amazon machine learning frameworks and infrastructure. Again, lower level services for the machine learning experts, those who program in TensorFlow, who have experience in an MXNet or PyTorch. You have access to the deep learning libraries like Keras, Gluon. That's for the machine learning practitioners. More importantly, also, you have access to the infrastructure, kind of our deep learning Amazon machine images and containers, and then infrastructure that has GPUs and CPUs, as well as right on the hardware itself on the EC2 instance, elastic inference. So you can run inference jobs directly on the hardware. We also have very purpose-built inference type instances known as inferentia. And again, lower level libraries like FPGA. But somewhere mostly, where, engineers kind of land, because not everyone's a machine learning practitioner. And for the most part, folks who are comfortable in, say, statistical programming languages like R are able to take advantage of our ML stack via Amazon SageMaker.
Sorry to interrupt, but I can't see your screen. I know another organizer can't see your screen. I don't know about other people.
I see.
I can't see too. That's great.
I see. Yeah. I see something that says your screen sharing is paused, but I'm sharing, so I think I need permissions. Sorry about this.
I can just rejoin and it'll be good.
Yeah. Just let I do see
stop sharing and try sharing again. Just see if it helps. I don't know. Thank you though.
Can you see it?
Yep, all good.
Alrighty, cool. All right, so I won't bore you with the first layer. The second layer is kind of programmers who are very comfortable in Jupyter notebooks. You can step through kind of statistical code as well as importing Python libraries to run your analysis and model hosting and all the rest on Amazon SageMaker. We have SageMaker Studio. You can augment a lot of your kind of training with human interactions via ground truth. So a number of different things that you can do, with your Amazon SageMaker Jupyter notebooks. But for everything that we talked about in today's session is higher level services where we call those AI services. So things like AI services that help your existing web applications, whether, you have a photo app, but you need your photos. You need your system to parse through incoming photos to make sure, they're appropriate, or you want to, identify objects, things like that. So you'd want to use a computer vision service like Recognition. We talked about Lex for chatbots. But then you'll see like search with Amazon Kendra. So we're trying to put machine learning and more, enrichment of search capabilities. Because, now, as we're indexing a lot of documents, but where's the context of a natural language processor in order to pinpoint exactly what you want to find within a regular search kind of sentence? And that's where Amazon Kendra would come in. Fraud detector is a good one where you already have an existing fraud detection system, but you want to front run that with Amazon Fraud Detector where, hey, you're a business person, you're in, loss prevention, but you're not a data scientist, but you know what to look for. So you would use Amazon Fraud Detector based on your 20 years of, experience. While you have 20 years of, loss prevention experience, you don't have 20 years of data science experience. But taken together, if you use one of these AI services, you're very able to rapidly accelerate and be productive. So how do we put, these concepts into just general users' hands? And this is where our AI educational devices come in. Here you'll have AWS Deep Lens. Deep Lens is kind of a service where we can put a lot of computer vision power locally to a device versus connecting back into the cloud. Again, it looks kind of but it's a computer, even though it's clunky. But it just, what we're trying to do here is to put, the capabilities in your hands to start testing things out. Now, with the Ring camera, everything is miniaturized into a very kind of discrete package, whether it's your front door or different cameras. But for AWS Deep Lens, it's really just to put everything into your hands, and it's clunky for a reason, because we want to show you the components, what to connect, and how it all works. Going one step further, we have AWS Deep Racer. What I do here at AWS as well, I'm part of the PIT crew. So we walk customers through how to put reinforcement learning into your hands. And what are those concepts? An easy concept for reinforcement learning in machine learning is self-driving cars. We'll get into that in a couple of minutes, but pretty cool service here. You have, as you can see, two dual deep lens cameras connected into the car chassis, a regular RC kind of car chassis. And here on top, you'll see a LiDAR sensor for object detection, object avoidance. It's a really neat way of kind of understanding what it takes to get your deep racer car to drive by itself, but more importantly, what are the concepts of machine learning that's driving self-driving cars. And in kind of our newly introduced service called AWS Deep Composer, it's kind of leveraging a concept in AI known as generative AI, where it will learn an existing kind of pattern. And once it learns that existing pattern, it's going to generate, completely new patterns, in this case, melodies or beats or rhythms, so to speak. So I know I mentioned Deep Racer in AWS Deep Composer. Just wanted to focus more on the generative aspects of machine learning. So on the left, you see a generative model. So a GANs network takes these two components, a generative model and a discriminator. So on the generative model, think of it as an orchestra. You have each individual in the orchestra is very skilled at their instrument. However, in order to operate in a setting where you are generating a concert, you want all the skilled individuals to operate in harmony. And how do we do that? Is that we have a conductor. So a conductor in an orchestra, you can think of as a discriminator. While they're not playing the instruments, they have a keen sense of what they're looking for. They have a critical eye to the flow and the rhythm of what the orchestra should be playing. So as the orchestra is playing, they're generating the music. And as you know, with a conductor, they have that wand in the hand. What they're really doing is trying to direct the orchestra to hit the pitches and notes the way he kind of envisions to present the concert. So this is in a generative adversarial network. The discriminator is important because as the generative model gets better and better at generating a rhythm or a pattern or a song, the discriminator also gets very, very good at trying to understand how proper the melody is. And as each side improves, we're able to then ensure that what the AI generates is as close of a match or as close to a pattern as the original rhythm, but completely different. So that's kind of what we're trying to do with Deep Composer. Is we're not trying to teach you piano, but we're simply going to walk you through the service interpreting a rhythm. And then once you have enough, training time to learn that rhythm, it's going to then start to generate something new. But the discriminator knows and learned the real song. And then as the AI is generating, it's going to, start to say, that's off and on. I have a scoring kind of mechanism to improve your GANs model. So again, reinforcement learning in a broad AI context, as I mentioned, and as everyone on the call here knows, artificial intelligence in a general and broad kind of concept, AI seeks to, kind of mimic what us as humans know instinctively. Humans can interpret data by, identifying, anomalies, pattern recognition very easily. And we don't even think about how we do that as humans. But within AI, building that kind of discipline out is, generally speaking, a broad tasks. So then, with machine learning, we're able to break that up into discrete components to mimic, our, human intuition, things like that. So within machine learning, there are 3 distinct disciplines here: supervised learning, unsupervised, and reinforcement learning. With supervised learning, I think for the most part, I think most folks have an idea. It's where you're, taking data sets, and you can use that data set to predict housing prices. You can use all that existing data to forecast demand for your stores. So just easily think of it that way. With unsupervised, you're taking a whole host of data from disparate parts. There's no training whatsoever on it, but what the machine learning technique is used to do is to identify anomalies. So think of it as like clustering. You have this huge data set. The AI or the ML is going to then try to recognize patterns of disparate data sets. So think of that as unsupervised learning. Reinforcement learning is where Deep Racer and Deep Composer come in. So a reinforcement learning is, it learns through a sequence of actions to accumulate maximum rewards. So with Deep Racer, the way we do self-driving cars is that the agent itself will try to go around its environment to understand where it can accumulate maximum rewards. With Deep Composer, the AI will generate a melody, and based on the trained discriminator, it's going to learn what it's doing right and what it's doing wrong, and it's going to start to focus and hone in on what it's doing right. Now, I think we've all had experience with reinforcement learning in the real world. Think of training your dog, or a sibling or something, or a very young sibling, where we want to reinforce positive behavior. So I know with my dog, if I want him to sit or stay or do any number of different behaviors, I want to reward him with a treat, because then it'll learn, hey, if I do this, I'm going to get a cookie. But let's say I come back from running an errand, and I see the kitchen in this state, definitely looking at me like it's not going to get a cookie. And that's absolutely right. We don't want to reinforce negative behavior, because dogs are very good at knowing what they have done to get a cookie and what they have done to not get a cookie. And again, as we are training our dog, we can do very basic kind of skills and whatnot. But with just enough training, we can get our dog to do pretty much about anything. And as you can see here, it's our famous circus dog. So reinforcement learning terms, this is why Deep Racer is kind of the easiest way to put these concepts into everyday users' hands. In reinforcement learning, we need an agent. Self-driving cars, an agent is easy. It's a car, and we have an environment. And again, that mental model is very easy. Again, with an environment, it's definitely a track, right? And a state. So a state is where it's in with the road ahead. And the way we get a state is that front-facing camera, and that front-facing camera is a deep lens. And then based on its state, what does it see in front of it will determine the next course of action, whether I remain going straight, I kind of ease into a left or a right turn. And these actions are driven by a reward, because a reward is what we're incentivizing the agent to accumulate. And then as it, steps through its environment, whether it continues to go straight or it goes off track, it's an episode. If you complete one lap without going off track, is an episode. But even if you go like 2 steps and you go off bounds, that's also an episode. So it's a collection of these episodes that make up the experiences that your Deep Racer will learn, especially for reinforcement learning. Let's double down on this one. Your reward function is the most important kind of concept in reinforcement learning. It incentivizes your agent to perform very specific behaviors. And these behaviors are what we determine as good behaviors to, complete a task. So what is that task? the task here is to reach the end of the racing line. Again, us humans, we know, the easiest way to get to the goal here is to go in a straight line. But again, with machine learning and machines itself, it's never seen this road before. So it doesn't know how easy it is to reach its goal. It just knows it has a goal. And the way we would do that is in that grid example, we want to highlight for the reward, highlight to the agent what the rewards are for either following a straight line or what would happen if you go off course. So you see here, because it hasn't seen this before, it's going to have to experiment. So as you see, it's saying, hey, what happens if I go left of center, right of center? It's going to say, hey, I didn't go off track, but I have some rewards. But hey, if I stay in the middle, I keep getting twos. So its entire kind of reason to be is to accumulate maximum rewards. As you can see here, it took a number of iterations before it started to understand where it was getting the most points. And then as it learns through these experiences, it will learn to accumulate. But for us humans, we instinctively knew going in a straight line would get us maximum rewards and points to complete the time. But, for the machine learning model, I had to go through these exercises to know where it was in relations to the track, as well as in relations to what the incentives were to reach the end goal. An easy way to look at this without the grid pattern is the deep racer. This is kind of what it's doing for the first half hour of your training. It has never seen this road before. So it's just going to go and say, hey, what happens if I do this? What happens if I do that? And as you can see, it may not look successful, but as it learns, it's going to really exploit its environment. So you're getting from what's happening on the left to exactly, in a mode where it's fully exploiting its environment and hence driving itself and making those driving decisions itself based on the experiences that it learned. Okay, and that's all I had for today. Are there any questions?
So yeah, I have a question.
Absolutely.
Yeah, so I was recently reading an article about self-driving cars, and self-driving car companies like Waymo, they have driven around it has driven around 2 million miles, but still they're not pretty much confident on bringing onto the road due to some reasons. But why is that?
Yeah, so that's a great question, because with self-driving cars, we're still not at the point where it's like a human brain where we can, let's say we all live in New England here, but even if we go to Colorado and there's mountains, we as humans already can understand what that means if we go on a road that, winds through a mountain. There's some ice, so we know instinctively and intuitively to slow down. But road conditions are so different, and the degrees of turns and all that. You can have a ginormous data set, but it still would not cover every single possibility that it needs to be trained on. So I think in the world of self-driving cars and even robotics, actually just being at Remars last week, we want to then take, hey, 2 million miles of real world driving should get supplemented with, millions and millions and millions of miles of simulated driving, like a simulated environment, simulated roads and conditions, textures and the like. And that's happening right now. But I believe, where Waymo is and was just in that very, very limit of having a giant data set. But you definitely need more data for the AI. And I think, what everyone's trying to do now is then saying this huge data set. There's two problems here. How do we get corporations to share their data sets to help each other out? And if they can't do that, and I do understand that based on, competitive nature of, private enterprises, but if we can, instantiate, technology for these companies to simulate their own kind of environments, we're able to then enhance, you know, the self-driving AI to then interpret a whole host of different environmental factors in any road situation. And I know with I'm speaking more in light of Zoox, which is a self-driving car company we acquired back in 2020. And they had a presentation last week on exactly that. They have, just like Waymo, millions and millions of miles driven. They also have, you know, data sets from universities, but even going one step further with their own data set, real world driving miles plus university data sets, they're still at a fraction of what is needed to then be fully confident that they can interpret any road condition anywhere USA or in the world. And the way Zoox is doing it is building out simulated road environments. They're adding, you know, thunderstorms, rain, even, you know, water conditions, snow conditions, ice conditions, times, you know, 1,000,000 to really, you know, supplement that data set. And that's happening right now. And the more simulated environments we're doing, the better the AI could at least, you know, interpret different variations of data. And I know also the trend now in machine learning is synthetic data sets. Another example of that would be like our Go stores. Before we, you know, in a Go store, you can use your phone with a QR code, but we're kind of enhancing that with palm reading. And the way they trained the AI to read palms was they only had a small subset of real human palms, but then they took, you know, millions of human palms and then used an AI to generate hundreds of millions of synthetic palms in order for the AI to have this giant rich data set. So long-winded answer to your question. I know, you know, Amazon, as well as all the other companies, know in order to enhance what they already have is to use simulated environments to generate synthetic data to supplement what they already have.
Yeah, thank you very much.
Out of curiosity, like how large are the largest data sets? And so on like AWS SageMaker, are you like training on single GPUs, or can you do like, I don't know, 8x A100s? And then how do you go to like multi-node training?
Oh, that's a great question. Yeah. So with AWS, you have a number of different types of GPU kind of instances, but then within those types, you can scale out, I believe the largest like 24x GPUs. I can get those details, but yeah, and that's just one type. And then within another type, you know, it could be more GPUs, less CPUs, up to like 24. They may be even more. And then we can get into, you know, having SageMaker instances on bare metal hardware, and that gets you even closer to those GPUs without, you know, extracting away. So a number of different possibilities of scaling up and out, and with multi-nodes, absolutely. So again, scaling up would be saying, hey, I trained this on 8 GPUs, but then I dialed it up to 24. But then you want to parallelize your training. You go, you know, SageMaker 24XL times 4. So again, it's all within your scope of budget and what you're able to do. Now, again, realistically speaking, you would have to know how large is the data set. And generally speaking, you would have to have pretty large data sets, probably orders of magnitude of what probably SpaceX or like NASA would have in their data sets to use, you know, 24, you know, XL times, you know, 16 or whatever. But again, the possibility is there. Okay. Just saw chat. No, you're not cutting me off here. I thank you for, you know, interjecting, asking really good questions. But alrighty. Any additional questions?
All right, so thank you guys so much for coming. We have another workshop starting around now on how to present your project, so be sure to attend that.